Welcome to our channel Circuits Analytica. In this video, we will discuss 10 questions from Common Emitter RC coupled amplifier. So this is the diagram of an RC coupled amplifier. Here voltage divider biasing is used. DC voltage distribution across resistance RC and resistance RE are 40% of VCC and 10% of VCC respectively, so that DC voltage drop between transistors collector and emitter is equal to 50% of VCC. DC voltage drop across R2 is equal to VBE plus VRE, and DC voltage drop across R1 is equal to VCC minus VR1. So this is the DC equivalent of RC coupled amplifier. Applying KVL to the output loop, we will get VCC is equal to ICRC plus VCE plus IERE. ICRC is equal to 40% of VCC and IERE is equal to 10% of VCC. VR2 is equal to VBE plus IERE and VR1 is equal to VCC minus VR2. Current flow through resistance R1, IR1 is equal to IR2 plus IB. Emitter current is equal to IC plus IB. As base current IB is very small, emitter current can be approximated as IE is approximately equal to IC. DC load of the circuit is RC. This is the AC equivalent circuit of RC coupled amplifier. To draw the AC equivalent circuit, we have to replace all DC sources with its internal resistance, and we have to replace all capacitors with short circuit. Circuit of RC coupled amplifier consists of a DC voltage source VCC and 3 capacitors CC1, CC2 and CE. So the DC voltage source VCC is replaced with a short circuit, and coupling capacitors CC1, CC2 and CE are also replaced with short circuits as AC resistance of capacitors is negligible. AC load is equal to RC parallel to RL, and input resistance is approximately equal to R1 parallel to R2. Question 1. What is the distribution of voltage drop across RC and RE under DC conditions? So distribution of voltage drop across RC and RE are 40% of VCC and 10% of VCC respectively. Which type of biasing is used in this RC coupled amplifier? In RC coupled amplifier, a voltage divider biasing circuit is used, which consists of resistance R1, R2 and resistance RE. What is the role of coupling capacitors CC1 and CC2? Coupling capacitor CC1 is used to couple input signal to the input of the RC coupled amplifier. Coupling capacitor CC2 is used to couple load resistance RL to the output of the RC coupled amplifier. What happens if CE is removed from the circuit? If CE is removed from the circuit, that causes an AC voltage drop across resistance RE, which acts as a negative feedback for the amplifier, which reduces the gain of the amplifier. Identify AC load and DC load in the circuit. AC load is equal to RC parallel to RL and DC load is equal to RC. Relate current flow through resistor R1 and resistor R2 when no input signal is applied to the input of the amplifier. When no input signal is applied or under DC conditions, current flow through resistance R1 is equal to 10 IB and current flow through resistance R2 is equal to 9 IB. Relate current flow through resistors RC and RE when no input signal is applied to the input of the amplifier. When no input signal is applied to the input of the amplifier or under DC conditions, current flow through RC is equal to IC and current flow through RE is equal to IE. What is the distribution of voltage drop across resistance R1 and R2? Voltage drop across resistance R2 is equal to VBE plus VRE and voltage drop across resistance R1 is equal to VCC minus VR2. So this is the voltage drop across resistance R1 and resistance R2 when no input signal is applied. What is the minimum and maximum value of output voltage? Minimum value of output voltage is equal to 0 and maximum value of output voltage is equal to plus VCC. Output voltage reaches the minimum value when transistor is fully on. So collector emitter voltage becomes 0 and maximum value of output voltage is equal to plus VCC when transistor is fully off. In DC conditions, voltage drop across resistance RC is VCC. Identify the possible problems in the circuit. So in DC conditions, normally voltage drop across RC is equal to 40% of VCC. If voltage drop across RC is equal to VCC, that means current flow through resistance RC is equal to 0. No current flows through resistance RC. So the first possible problem is transistor is damaged. Second possible problem is resistance RE is loosely connected. Third possible problem is either resistance R1 or resistance R2 is loosely connected so that transistor's base current is equal to 0. Thanks for watching Circuits Analytica. Enjoy learning.